Hello again. Let's look at this example right here. D by dx of the cube root of x. Well, guys, that's d by dx of x to the 1/3 power. We bring down the 1/3, and so we get 1, and then we subtract 1 off of this 1/3 that was up here. So we get negative 2/3 up here and 1/3 down here in the coefficient. But remember, this is good, but let's do some algebra. We're done with the calculus here, but we need to do the algebra. So we bring the x to the negative 2/3 down here with that 3 on the denominator and make it x to the positive 2/3 after we jump it down. So again, we have x to the 2/3 down here. Now, for good manners, let's rationalize. So remember, 2/3 plus what equals 3/3? Well, namely 1/3. So we need 1/3 here. We multiply the bottom and the top by x to the 1/3. Because I know that if I do that, this 2/3 will add to this 1/3 in the exponent, and I'll get 3/3, which is just 1. So I'll have x to the 1 power, which is x itself here. So I get x to the 1/3 up top, which is the cube root of x, and I get 3x on the bottom. And by associativity, again, we went ahead and we multiplied this guy times this guy. And by the laws of exponents, x to the a times x to the b is x to the power of a plus b. Okay, d by dx of the cube root of x squared, that's d by dx of x to the 2/3. The 2/3 comes down. I subtract 1 off the 2/3 and get negative 1/3. The 1/3 comes down. Down here, well, the negative 1/3 comes down here as positive 1/3. That is, or I should say x to the power of positive 1/3. But now remember, we need to add 2/3 to 1/3 to make it x to the 1 power. So I multiplied the bottom by x to the 2/3, and I stuck it in the middle. You could just as well stick it on the end by commutativity. And so I stuck x to the 2/3 here and x to the 2/3 here. But remember, guys, x to the 2/3, that's just the cube root of x squared. And the whole point of doing that was to have this on the bottom. X to the 2/3 times x to the 1/3 is just x itself. Remember that 2/3 and 1/3 give you 3/3, but that's just understood 1 up here. Okay. So moving on down the line. Now, if I have something like, here's a product rule, x to the 10th times the 6th root of x. Remember, you could, well, actually, we could do the product rule. I took another way out. I just used the power rule. And again, this whole business of, I need to call it by its name. Up here, when we took the 2/3 down and subtracted the 1 and got the negative 1/3, that's called the power rule. Okay. So let's go down here. We could do the product rule. That would be fine. Yes, I know. But I take another approach. Here's what I do. You notice that, remember, the 6th root of x to the 60th would be 10, x to the 10th, because 60 divided by 6 is 10, so I'd get x to the 10th. But I want to go this way. I want to write it like this, because I have a 6th root here that would match this 6th root here. So I would have the 6th root of x to the 60th times the 6th root of x to the 1 power. So now what that amounts to is, now I can bring these together. I'm assuming that x is positive, as always, with these kind of radicals. Well, I can bring these in together, and remember, x is just understood to be x to the 1 power. So I just, by law of exponents, I add these together, I get 61 here. So I have d by dx of the 6th root of x to the 61. But aha, now we can just write this in fractional form as d by dx of x to the 61 over 6 power. And then, well, I do the power rule. I bring down the 61 over 6, and I subtract 1, but that's just 6/6. And so I get 61/6 x to the 55/6. Now, that's good, but let's see if we can clean this up a little bit. Now, that's 61/6, but that's x to the power of 9 and 1/6. That's the mixed number 9 and 1/6 in the exponent. So that's 61/6 times x to the power of 9 and 1/6. But now we can remember, by the laws of exponents, we can break this off. So it's 61/6 times x to the 9th times x to the 1/6. And really, these time signs here are completely superficial. We can leave them off if you so wish, and we will. So we just have that. Nothing wrong with them. They were just superficial. So we have all this, but hey, we're practically done. That's just 61/6 x to the ninth times the 6th root of x. And to be honest, deep down, this times sign is actually superficial as well. But in Microsoft Word, we have this issue of this 9 and 6 being too close together. Hey, we could write it like that. Well, I kind of wish I'd have been doing that for a while now. It's okay. But that kind of looks messy too. Let me just put that times sign back there. Pencil and paper, you can just put a little space between them and it's understood that everything's being multiplied. But because of Microsoft Word, I have to have this times sign right here. It just is what it is. On pencil and paper, you can put this times sign. There's nothing wrong with putting it, but you don't have to. Okay. But anyway, if f is differentiable at all real numbers, then let's move on down. So we're assuming f is differentiable, that it has a derivative everywhere. So d by dx of f of x squared. Now by the chain rule, we let u equal x squared, and we get d by du of f of u times d by dx of the u term, x, which is x squared itself. So now d by du of f of u, we're just going to name tag. We're going to call that f prime of u, and it skipped a line on me. So we're going to call that f prime. So d by du of f of u is f prime of u. Now we know that d by dx of x squared is 2x by the power rule. Okay. So, and just out of good manners, this is correct, but it's good manners to have the 2x in front. And so, and you know what? So we just have 2x times f prime of u. You can put the times sign in between them, but I don't have to. You kind of need to put it here. It'd be bad manners if you didn't put the times sign here. Another way to write this, you'd have to have parenthetical. And because it would be, but to me that feels awkward. Let me just go ahead and reinsert my times sign. So let's just bring it back to the way it was. The other way was correct, but it looked awkward. It felt awkward. This is better. You need the times sign here. You don't particularly have to have it here unless you just want it. And then it skips a line on me, so I have 2x times f prime of u, but now I got to replace u with x squared, so I have 2x times f prime of x squared. Where f prime is d by dx of f of x, that's the way we defined it. Of course it is. That's what f prime means in the first place. And u equals x squared. Guys, when you do this problem, well, let me get my spacing straight. When you do this problem, be sure to tell your professor, let me move this down. Don't leave this out. This line that I've got highlighted here, don't leave it out. You need to tell him or her that f prime of x is d by dx of f of x and that u equals x squared. Because f prime can be ambiguous. Watch out. You know, it's handy. F prime is a lot nicer to write than having to write d by dx of f of x every time. But you do need to do this last line right here. And you have to let your professor know what u equals x squared for sure. And you probably should do this line here. You can lose points. So please include this. All you got to do is just include this, and you've covered your bases, okay? Don't let the little things run it for you, okay? Now, again, we're going to let f prime be d by dx of f of x, so do include this. With that being said, d by dx of f cubed f of x is 3x squared f of x plus x cubed f prime of x. So what I do, guys, is I derivate the x cubed term first, and I get this 3x squared here. You remember the product rule. Let's deploy the product rule. We derivate the x cubed, we get the 3x squared, but we leave f of x alone. And then plus, on the second guy, we leave x cubed alone and derivate the f. So we get f prime of x here, okay? And where we just note the obvious. We defined f prime in the first place to be this, okay? So let's look at this. If we got d by dx of the sine of x over f of x, now that's low d high. So we do low is f of x, high is sine x. So we do low d high, but the derivative of the sine is a cosine, so d high is the cosine. And then minus high, which is the sine, d low, which is f prime, all over low squared, which is f of x parentheses or brackets or whatever squared. I chose brackets. You can use parentheses, whatever. And that's it. We can't really go any further because I've not really stated what f of x is. we're assuming that f is differentiable. Otherwise, I'd be in a deep trouble that we couldn't necessarily do this otherwise. It wouldn't make sense. Now, watch out for something. Now, this is not f of x squared. This is the square of f of x. That's not the same thing, okay? Be careful. D by dx of the square of the function. Now, with this time, we let... oops, I forgot. I broke my own rule, didn't I? We let u equal f of x. Oops. I need to practice what I encourage. So here, we replace u with f of x. So we have d by du of u squared times d by dx of f of x. Okay, now if d by du of u squared is 2u, and we're just going to call this guy right here f prime of x, and then you replace u with f of x, so you do have 2 f of x, f prime of x, where f prime is, of course, this, and u is, of course, this. We define that from the get-go. Now, guys, be careful about something. I hope I footnoted this. Let me just, no, I didn't, and I wish I'd have done that. Now, it's a very different set of affairs if I would have derivated f of x squared. Now, this is not the same thing. What I'm going to do this time is I'm going to put the square inside here. This is not the same as the guy immediately above. This, by the chain rule, what I do is I would let u equal x squared. So I'd have d by du of f of u, and then times d by dx of the u term, oops, so times d by dx of my u term, which is x squared. We're letting u equal x squared. And then that would naturally give me f prime of u, and then times 2x, and that would naturally give me, let me go down a line, and I may have to go down to the next page. So let me go down a line, oops, and so notice here, with this guy here, I got 2 f of x, f prime of x. I'm not going to get that down here. This is not the same guy. So I have 2x times f prime of u. Just out of good manners, I'm going to put the 2x in front. And I don't have to write the time sign this time. I can, but I don't have to. You could say 2 dot x dot f prime of u, but nah. And then, so that's 2x. Now f prime, now u is x squared, and that's it, we're done. Where, now of course we're done, except that I do need to note that u equals x squared, which is very different than from the last problem, and f prime of x, let me go down a line, I hate it when it fonts, and then and f prime of x equals d by dx of f of x, and then it skipped a line on me again. I may just have to live with it. It's a pet peeve when it does that, but it's, well, I guess I brought it on myself. Okay, there we go. Okay, so, and I just noted my u. Notice that in this, I just noted what my u is and what my f prime is. Guys, notice that in this problem, I ended up with 2x times f prime of x squared, whereas in this problem, I ended up with just, this is very different. We're not squaring x, we're squaring the whole function. We're throwing x, throwing x into f, we're getting f of x, and then we're squaring it after the fact. In this problem, and then we're doing the derivative after that. Now down here, we square x first, and then do the function, and then do the derivative. That's the difference, okay? If y equals f of x, we're going to let dy by dx stand for d by dx of f of x. This is actually a little bit sloppy, but it's so common we may as well do it. It's shorthand. Deep down, the derivative is an operator. It's not just a fraction, but we'll live with the abuse. It actually acts like a fraction so well, as long as your functions are pretty nice, that you can get away with treating it like one. But there's at the end of the day, there is more going on. We're taking a limit and all that. But you really can't say that. Later on you'll see that dx by dy and dy by dx, as long as neither one is 0 and they both exist and all that, they're the reciprocals of each other. Particularly, well, in certain nice situations, they're the reciprocals of each other. If they both exist, if certain nice things are true, then they're the reciprocals of each other. I don't really want to get off on a wild goose chase just yet. But if with certain things granted, yeah, dy by dx is the reciprocal of dx by dy. But we'll talk more about that later. Okay, the letters x and y are not sacred. We could just as well use s's and t's, you know. But anyway, in physics they do sometimes. Now here's another low d high. D by dx of e to the x over the square root of x. Again, low d high minus high d low over low squared. But hey, so if you square the square root, that's just x himself. We could actually go ahead and just do that. But anyway. Now here, radical x times, well, d by dx of e to the x is easy. That's just e to the x. Now this one's a little messy. If you do d by dx of the square root of x, remember from previous videos, that's 1 over 2 radical x. You remember that's x to the half power, and you get 1/2 x to the negative half power, but that x to the negative half jumps back down here as x to the half, which is radical x. Okay, so that's a little sloppy, but there it is. And then that's just x down there. And guys, and what I do here, I'll go ahead and do something else up here. Remember, you stick another radical x down here to go with this radical x that's already down here. But because you do that, you got to multiply the top by radical x. And so we get, and you go ahead and multiply the top by this e to the x because it's already there. It's already staked its claim. So we bring that e to the x, we multiply e to the x by 1, get e to the x. And we insert that other radical x up here and down here, but radical x is just, that's the whole reason we did this. We get just plain x down here. We rationalize that denominator. That was our motive. So we have minus radical x e to the x over 2x. Again, I stuck a radical x down here and a second one down here, and I stuck a radical x up here and multiplied it by 1, but that's just radical x itself. But I go ahead and bring that e to the x up here to be with that radical x. And you could, by commutativity, you could put the e to the x in front. You could say rad x e to the x, or you could say square root of x e to the x, or e to the x square root of x by commutativity right here. Either way, it's fine. They're the same. Okay, now this is good, but it's at the same time it's messy. So what I'm going to do is I'm going to get a common denominator. If I notice this is already over 2x, so I'm going to multiply this guy right here by 2x, and I get 2x times the guy that was already there, rad x e to the x. And then that allows me to put everything, I put it all in the same numerator and I put it all over 2x. I kind of skipped the step. What you can do is you can go ahead and you can turn this guy into 2x radical x e to the x over 2x here, and then minus this guy up here over 2x, and then, but since the denominators are the same, you can just bring them together like this, okay? Okay, so I have this guy. Now this is messy as well, but it's a messy that we can fix quickly. We can just take this 2x and bring it down here. By the laws of algebra, we can take this 2x, bring them down here, and multiply them by this x here. 2x times another x is just 2x squared, like this. So what we got is we got just the same numerator over 2x squared. And then now, you can stop there. Your professor, I'm sure, would be more than happy if you got this far. A final thing you could do, if you ever have an ABCD kind of test or quiz, if they may give it to you possibly in this format, you can filter out a radical x e to the x, and that leaves you with the 2x minus 1 here, if you filter out radical x e to the x like this. But that's not the most important part of the problem, but they may put it to you in that form, so do be aware. And guys, that's pretty much all for this video. I hope this step right here didn't throw you off. I went ahead and skipped the step. Again, I just stuck the 2x here. What I did was I wrote this guy right here as 2x times the rad x e to the x over 2x. This 2x here and this one here balance, okay? But I want the 2x to be here so I can have this common denominator here. Guys, I'm out of time. That'll be all for this video. Thank you. and we'll move on to the next video. Bye.